Okay, so the plan now is to do a kind of quiet video about everything that we saw in the previous video, which was about making this counter emote. And what we did is we started by stopping the counter and clearing the counter, so it's effectively completely quiet and it's not showing us anything. So before we get started about the actual prop itself, and its interactions, I think what I'd do is I'll tell you a little bit about how it was made and what bits go into it. For absolute clarity, this is effectively what I am selling as part of, or what we are selling as part of the automated film props company. And this is effectively an ESP32 that can drive a whole range of devices. So it's driving one of these TM1637 displays, which is a simple 7-segment display. Now, we can drive much more complicated pieces of equipment, but because I wanted to keep this super simple, and let's take the volume of this machine down, because I wanted to keep it super simple, I thought we'd start with like the simplest use case. The prop itself came from me watching the beginning of Dead Reckoning. There's a submarine scene, and I saw a number of these things in the background. So what I did was designed up some plates like this and some housings like this. And I thought what would be interesting is design the components that would fit into the housings like this, and make this the same 20mm thread that you find on standard electrical glands, so you could make those kind of connections. In this particular case, I haven't used electrical glands, I've used another part. This valve housing, again, fairly straightforward. It's got threads on it, which makes it quite interesting because they're kind of functional threads. And then this thing's got the bezel on it, and if I just pop this in here like this, you can see that counter effectively fits in there. And then there's a pile of cables that come from this counter to this module, and this module is what's driving the counters and listening to the devices. Now, the module itself communicates over Wi-Fi, and it uses WebSockets to a central server, which is, where have I got my little central server? It's somewhere on the floor back there, but it's basically a very small box like this. It's just a tiny little microcomputer that's running a WebSockets and a Django server, actually, to serve the web pages. So what this thing does is it runs multiple tasks in it. So it's got a task that is dedicated to driving the counter. Let's get the counter started. So we've got this task that's sitting there indexing this counter every second, and if we send it a different kind of event, the counter will behave differently. So if we send it the random period event that we talked about before, what it's doing is it's telling that thread that's running in this device to randomize the time that is used between these things. And then typically, we could say, let's send it a random value, let's put it into hex mode, decimal mode, stop the counter, give it a normal count. And the reason we do that is so that this prop is ready to go for every take. And the other reason that we do it is we try to keep the behavior and the interactivity of the prop away from the prop itself and defined in sequences, rules and events, which means that if you're on set, you can do some things like connect props together, or you can change the brightness of things. In fact, we saw that earlier. We could set the brightness of this low, which we might need to do because it could be that when you're filming a particular sequence, this is just too bright, or we can set it bright because effectively at a point in time within the prop, we want to draw attention to what's happening. The other interesting things that are happening within that task is the ability to do the glitching. And the glitching is done in two different ways. It's basically glitch level 1 and glitch level 2. Glitch level 1 that you're seeing here is just modulating the brightness of the device. It's actually messing a little bit with the period as well, because these events are cumulative. So you can send an event for jitter, you can send event for glitch, and you can send event for rate as well. So for example, if we go to frenetic, that's how you get that. And if we go to glitch 2, this is the next level. So this is where we're displaying valid numbers, but randomly, depending where we are, we're asking the display to display it's actually just a binary value between 0 and 128, and that's what happens to make that do that. Let's make that quiet and send it back to normal. Now the next thing that's happening is we've got a couple of other tasks that are running, and in fact the way it works is there's effectively a task or an interrupt routine per button. And on this particular prop we've got 3 buttons. This button here is actually designed to work completely local to the prop. I don't think that's a particularly good idea, but that's the way I did it for this demo. And this is the one that does the calibration. And the reason that it's useful in this case to do it local to the prop is because at some point we want to keep the value of the counter and restore the value of the counter. The next one, which is test, is interesting because test is going to issue an event, and then the server's going to send a sequence back, which is going to make this go into a particular mode. But this event, which is consumed by the server, will also drive this prop over here. So let's see that happen. We send the test, we get the fail, and then we're going to get this purple accent on this pulse prop over here. And if we send it back to normal, in fact, one of the buttons, it will be this button here, pushing that in, that's a rotary encoder with a button in it. That then sends the normal event to this and to this. I mean, technically it's a normal sequence, so it's actually a string of things. And I think what I'll do is I'll, when I'm putting this video together later, I'll take a shot off the code to show you how simple the events are. The next thing is there is a task that is listening to the rotary encoder. And the rotary encoder, because of the speed of interactivity that we want, is actually driving the counter object directly within this. So it's actually task-to-task communication. So there you are. One task is communicating with the other task. And the reason that we think that this is important, and we do this with some other props, which you can't see, there's one with a joystick that's got a throttle control here, is because we want any actor or talent that interacts with this prop, we want the actions to be direct and affordant. So as we do this, this changes. And if we needed to do it at fine rate, you can see that with a bit of gentle movement, it's fine. With a fast movement, you know, it's quick. And it's giving us the impression that the prop is not only a prop, but it's a simulation of what the narrative is trying to tell us. Then another interesting approach to this is the way that this prop can be sent a command to do a countdown, and when it finishes the countdown, it sends another event out. In fact, the event it sends out is alarm 50, because this prop here within the network is called counter 50, so it's going to send out an alarm 50. So if we ask it to do a countdown, it will count down from 5, and then when it finishes its countdown, it'll drive that pulsing LED, but it will go back and send a signal to this prop. So this prop has that red pulsing within it, whilst this has the red pulsing here. And again, from a separate web browser here, I can just click and send a normal event to that, which will put that into a normal state. And it puts this prop here into a normal state. Now, the beauty of this architecture, which is effectively WebSockets, publish and subscribe, is that you can have a huge number of props on the same network. And the props can be battery powered, so you can drop them around the set. Now that, of course, could be an issue for some people. So what we've done is we've created a heartbeat function within each one of these props. And the heartbeat function says, I'm here, I'm listening for these events, and my battery level is whatever it is. And it's actually got some thresholds depending on whether it's high or low. So as a prop master or an assistant director, you can just look at that page and go, well, that prop's probably only got another couple of hours to run before we put a fresh battery in it or take it off and recharge it. And it gives you this really easy way of knowing that all your props are present and correct. Sorry, not connect. Correct. So I think that has given you a kind of a basic view of what we do at Automated Film Props. We're seeking to make these modules that you as prop makers can go and incorporate into the frankly better props that you'll build, and you can create that interactivity, automation and animation that you need to support whatever narrative it is that your customers are trying to get you to interact with and bring to life. So there you are. I think I'm going to finish about there, other than to say that these components here that make up this prop, we've used them quite a few times. Somewhere we've got 3 of these in a row, and in terms of a freebie, we are thinking about publishing the STLs for these. Yeah, well, this is the calm marketing approach, so there's no real call to action. But as always, if you're interested in this stuff, please get in touch.